So we were stopped. We were discussing about, yes, we were discussing on conductance, specific conductance and molar conductance. So that was the previous class. The topic was conductance, specific conductance and molar conductance. So we discuss on these topics. So now today the topic is variation of this conductance. Let's say see specific conductance, kappa and molar conductance or equivalent conductance. So variation of this conductance, see molar conductance, specific conductance, molar conductance and equivalent conductance with dilution. So with dilutions, what is the effect on this conductance, molar conductance, specific conductance, molar conductance and equivalent conductance? So that is we will discuss in detail today. So dilutions means we are adding the water. Dilutions means on adding water. So on adding water, if a concentration, if any electrolyte is there, let's say it's NaCl, and if you add water, then the concentration of NaCl will decreases. Yes, concentration of NaCl or any electrolytes concentrations on adding water, this concentration or any electrolytes will decreases. It means dilutions means dilutions if I increase or if I add water, then concentrations is decreases. So variations of conductance or specific conductance, molar conductance and equivalent conductance with dilutions. It means with adding water, what is the effect on this conductance, molar conductance and specific conductance? Means with decreasing the concentrations, what is the effect of this conductance, specific conductance, all this. So we already discussed that. Let's say here any conductance I take, let's say any conductance, so any electrolytes, let's say I take NaCl, this electrolyte is here and I have taken the two rods, or I will draw the picture. Let's say and let's say I have taken any electrolytes. Let's say the electrolytes is NaCl. This is positive and this is negative, and this is anode, this is cathode. So what is the conductance? Conductance means how much electricity flow in this solution. Conductance means, what the conductance says, conductance means flow of electrons, or no, yes, the flow of electron in these solutions. So let me define very. So I will say sorry. Conductance C means flow of electrons or to all ions of the electrolyte any electrolyte. Let's say here NaCl, then I write NaCl. So flow of ions means here ions are Na plus and Cl minus, ions are Na plus and Cl minus. So flow of electrons, so flow of electrons upward to all ions of the electrolytes through the solutions, or in the solutions. So in these solutions, the flow of electrons upward to all the ions of electrolyte, that is called conductance. Means here, let's say if I will draw in, okay, let's say here Na plus Cl minus, Na plus Cl minus is there. Okay, so here let's say the huge amount of ions, means C1 mole means 6.0 into 23 10 to the power 23 moles of electron, moles of number of particles are there. So huge number of ions will be there, but I am taking considerably very less. So for understanding, let's say 2 Na plus is there and 2 Cl minus is there. Just for assumptions, just for clear the concept, these amounts of 2 Na plus is there, 2 Cl minus is there in these solutions. Okay, so total or let me say I will add little bit more. So let's say 1 2 3 4, let's say 4 Na plus and 4 Cl minus is there in these solutions. So total number of ions will be 8 ions is there. Okay, now again what I say is that this is for conductance, and for specific conductance, let me draw. Okay, so same, this is positive, this is negative, so this is positive charge and this is negative charge, this is anode and this is cathode, same things. Okay, so now, so here also same amount of power Na plus and power Cl minus is there. Okay, so let me draw, sorry. Okay, so here Na plus Cl minus, Na plus, Cl minus, Cl minus, Cl minus, Na plus is there. Okay, so now for conductance, what it says that for specific conductance, what is the definition? Flow of electron offer to all ions, let's say here Na plus and Cl minus of electrolyte NaCl in 1 ml of solutions. So previously defined that what do you mean by specific conductance, what do you mean by conductance. So conductance means in the solutions, this is not specific. For specific conductance, we specify that in 1 ml of solutions, how much how much electrons able to flow, how much we offer the electrons to the ions of the electrolytes, that is called specific conductance. So previous class we have discussed this. So what it mean that, so it says that this is, previous class we already discussed, we take this as, this area as 1 centimeter square and length between this is 1 centimeter. So we take that, we assume as this. So if we assume this is, this area will be 1 centimeter cube. 1 centimeter means 1 ml. So this picture we can draw for understanding. The above picture we can draw so this is 1 centimeter cube, that is equal to 1 milliliter. So this picture, let's say this is 1 centimeter, the distance between two electrodes is 1 centimeter and area 1 centimeter, total equal to 1 centimeter cube. So this area is equal to 1 centimeter cube. So for if you look like this, then we can't imagine. So what I take this picture, I draw like this. So this area means this is electrodes, everything include, means within this area 1 millimeter. So here also I am taking within this area, but we cannot imagine by we can't imagine by looking at this picture, because here it says this 1 centimeter and the area of 1 centimeter we assume, then it will look like this. So within this 1 ml of solutions, how many electrolytes will be there? So electrolytes will be spread as usual at the same manner as it is spread. Let's say Cl minus is here, Na plus is here, so Na plus is here, Cl minus is there, Na plus, Cl minus. So within this 1 ml of solutions, how many electrons, how many ions are present? So within these solutions, ions are present, like for Na plus and for Cl minus, if you are taking these examples. But within 1 ml of solutions, only 1 Na plus and 1 Cl minus has come, because these ions are equally distributed, homogeneously distributed. And if you find that within this amount of area, means within this amount of volume, how many electrolytes are present, how many ions of electrolytes will present. So since these are distributed in a homogeneous, then if you find a unit 1 ml of 1 ml volume of these solutions, then what you will find that if you take an example, this 1 Na plus and Cl minus is there. It means that here the conductance is more number of ions. Conductance means flow of electrons. So here the if concentration of electrons, here the concentration of electron is high, or not concentration, the number of electrons is high, because whole that per electrons per whole solutions, then we say that per Na plus and per Cl minus is there. It means the number of electrons is high in this solution, so the conductance is high. But if I say that sorry for that interruptions. So what I did that, I'm very sorry. Okay, so with dilutions what will happen? So here, suppose here, so this is uniformly Na plus and Cl minus is there. Let's say 1 2 3, yes, another Na plus Cl minus is there. So uniformly, so everywhere the ions are distributed uniformly. So on adding water, then what will be the effect on the conductance and specific conductance? That is the questions. So here if I add water to these solutions, if I add water, I mean that is dilutions, what happened? That more amount of water I am adding. Yes, more amount of water I am adding. So let's say I am adding more amount of water. So if I add more amount of water, then but the number of ions it's same. I'm just adding the water only. So number of electrolytes, it means number of ions of the electrolytes, it's same. So let's say so I add only water, but the number of ions is same. So if I add number of waters, let's say this NaCl electrolytes, this is going to break Na plus and Cl minus. Okay, after dissociate also, this Na plus and Cl minus have the attractions. Electrostatic force of attractions is there. Electrostatic force of attractions is present. But whenever I am adding the water, means I am adding water, then what happened? This Na plus here, and within this area water molecules will come. It means water molecules will come. So if water molecule will come, then the distance, the attractions between this Na plus and Cl minus will decrease, because in between these water molecules has came. So if water molecules has came, then the attractions between these opposite charges will decreases. If the attractions between these opposite charges decreases, then this Na plus and Cl minus in solutions freely move. So if they are freely moved, then the conductance will increases. Conductance means movement of ions, so conductance will increases. So this is happen in conductance. So if we are diluting, if we are adding water, then conductance will increases. So here the Cl minus Na plus will be move far away. So the ions will move far away, and the attractions between these ions will decreases, so the conductance will increases. Then what happened to this specific conductance? So if for the specific conductance also, if I add water, I am doing dilutions, then what happened? Here also same picture will happen. That same way, if I add water, okay, all I have to draw a picture. So after adding water, the ions will move far away. It means that ions will move far away, means Cl minus Na plus. Let's search 1 NH here. Like this. So here what happened, that after adding water, that the attractions between the ions ions is decreases because water molecules came inside. But within this 1 ml of solutions, now the number of ions only means density within this 1 ml solution is decreases. Previously the number of ions were 2. The 2 means total is 4 ions were there, but now due to the additions of water, the ions they move far away with each other, so the density of this unit volume, but 1 ml of solutions, the density is decreases, means number of ions within this 1 ml solutions is decreases. It means that, so here we are interested, here our study area is whole solutions, but for specific conductance our study area is only this solution, this amount only we will study. For this case we will study for the whole solution. The whole solutions, the conductance is increases, but within this 1 ml of solutions, the number of ions decreases. Although Na plus and Cl minus, due to water molecules they are free, but the number of ions decreases. So if number of ions decreases, means conductance is decreases. Okay, so because number of ions is less, so if number of ions is less, then conductance is decreases. So for that, conductance on dilutions, this is increases, but specific conductance kappa on dilutions it decreases. Okay, and here we added that, let's say this is A, here we added that strong electrolytes. Then what about of the weak electrolytes? So if I add same for weak electrolytes, let's say CH3COOH. So this is partially dissociate, CH3CO minus plus H plus. So T equal to 0. Let's say this is, let's say I have taken 1 molar, 0 0, and T equal to T equilibrium. This is, let's say 1 minus alpha, then this is alpha alpha. So in the solutions, this concentration is present, means CH3CO is present, and alpha is very less. It means that CH3COH, CO minus and H plus concentration is very less in the solutions. Okay, so very less amounts. It means that is alpha value is, let's say 0.01. So very less value is there in the solutions. So whenever I say and if you have the electrode rods, and in this electrolytes is CH3COOH. So a huge amount of CH3COH is present and very less amount of CH3CO minus and H plus is there. Okay, so whenever I add the water, then what happened that whenever I add the water, in that case so huge amount of water says can I add the huge amount of water, then what happened this. So now due to additions of water, this CH3COOH that dissociate into CH3CO minus plus H plus, and this is weak electrolytes. Weak electrolytes means current flow of very low amount of electrons is there. So CH3COH is a weak electrolytes. Since this is weak electrolytes, so it only partially dissociate, means very less amount of CH3H plus is there, and we are adding that water means with water what it will come, H plus and OH minus, means overall after adding the water we increasing the concentration of H plus and OH minus, overall increasing the ions. But for strong electrolyte, let's say NaCl, this NaCl is completely dissociate. NaCl, it is completely dissociate. Let's say T equal to 0, 1 molar is there, and T equal to T equilibrium. This completely dissociate into this and this. So at solutions, already huge amount of Na plus and Cl minus is there, and water is completely weak electrolyte compared to NaCl. So this will give very less ions, but so this ions has no effect on it because already huge amount of Na and Cl minus is there. But for this case, for this weak electrolytes, since this is very weak electrolyte, so this is very less amount of CH3 CO minus and H plus it will give. We say that very less amount, that is 0.01. So compared to 1, 0.01 means very less value. So compared to this, water is a good electrolyte, so it will give H plus and OH minus. So this H plus and OH minus act as a electrolytes and it will do the conductance. So if you are adding that water to the weak electrolytes, then overall ions, number of ions is increases. So if number of ions is increases, then the conductance is increases in huge amount. Conductance increases in huge amount. Okay, so but for strong electrolytes, it already the for strong electrolytes, NaCl is already completely dissociated, so it already have a good conductance. So after adding water, it only helps to decrease the attractions between the two ions. But for the weak electrolytes, it helps to increase the number of ions. So the conductance is increases in a huge amount after adding water. But for strong electrolytes, it only helps to decrease the attractions between the ions. So after additions of water, there is a very less amount of increases in the conductance. Let's say we will discuss it clearly for strong electrolytes and for weak electrolytes. So strong electrolytes, let's say this means very less amount of increase happen, means from here to here very less amount of increases. Let's say this is lambda m, this is concentrations, so very less amount of increases. We will discuss this graphs. So very less amount of increases has happened. But for weak electrolytes, after adding the conductance, what happened, this huge amounts will increases. So here, from here to, it increases very, means after adding water, increases, or it may be like this. So very less amount of increase happen. But here, after adding, means this is concentrations. If concentrations is increases this direction, then dilutions will increases this directions. So if you are adding the dilutions, means if you are adding dilution, this is huge amount. But here, your dilutions here means dilutions will this side, because concentration is 1 by dilutions. So if we add in the dilutions, then very less amount of increase has happened, marginal increases. But here, after adding dilutions, huge amount of increase happened, because for weak electrolytes, number of ions increases due to dilutions. And for strong electrolytes, on dilutions, charge separations increases or helps to freely movement of ions. So it helps, dilutions here helping to freely movement of ions. Here the dilutions helping to increase the number of ions. So here for weak electrolytes, it increases huge amount on dilutions, but for strong electrolytes partially increases, because here also it helps in freely movement. Okay, so conductance, the effects. So overall in conductance increases on dilutions, but the specific conductance will be decreases on dilutions. Why? Because we already discussed that on dilutions the number of ions in the solution increases, but within this 1 ml of solution, within this unit volume, the concentrations of electrolytes will decreases because it spread it away. So if it spread means it is uniformly spread, so the binding of the ions within 1 ml of solution is decreases. Before, when this is a less amount of without water, but that the concentration this Cl and Na plus where the density is high, so within binding a electrolytes in a unit volume was high, but after adding the electrolytes spread away. So if they are spreaded away due to water, then the binding of electrolytes in a 1 unit of volume has decreases. So for conductance we are finding for specific conductance we are finding the conductance in a 1 ml of solutions. So in 1 ml of solutions, number of electrolytes decreases means concentration means conductance or specific conductance is decreases. But for the conductance we are finding the conductance in a whole solution. So overall in the whole solutions, since on adding water the ions freely moves and number of ions also remains same, so conductance is increases. But here the number of ions decreases. Previously without adding water the number of ions were 4. Here let's say 4 ions were there, 2Na plus and 2Cl minus were there. But on adding water within this 1 ml of solutions, only 1 Na plus is there and 1 Cl minus is there. So it decreases by 2 ions. So if decreases by 2 ions, so we see that number of ions as decreases. If number of ions decreases means conductance decreases. Conductance means movement of ions. If ions is decreases, then obviously the conductance will decreases. Okay. Now the next we will discuss what is the effect of dilutions on molar conductance and equivalent conductance. Effect of molar conductance and equivalent conductance on dilutions. So we see that molar conductance is kappa by molar, and we know that molar equal to number of moles by volume in upon volume in 1 liter solutions. So we have already discussed that number of moles, if we taken 1, then molar equal to 1 upon volume in 1 liter solutions. So this one I can write m equal to 1 upon b. So lambda m equal to so here b equal to 1 upon m. So I can write this is equal to k into 1 upon m. So 1 upon m equal to k into p. This is molar conductance. So we already discussed that this kappa means specific conductance is decreases on dilutions. We already discussed. And volume is obviously increases because we are adding water. So increase on dilutions. Volume all means we are adding water, means amount of water you are adding, means volume will increases on dilution. Volume, if you are adding anything, then obviously the volume will increases. So for molar conductance, here kappa is decreasing and volume is increasing on dilution. So what is the effect of that lambda m? So molar conductance. So molar conductance is due to these two value. So one is decreasing and other is increasing. Then so how will you decide which factor is dominant? So from experiment we find that volume factor dominate over kappa. It means lambda m. So if this factor dominates, then this is increasing, then this will increases because this factor dominates. So from experiment we get that volume factor is dominant over k. So lambda m increases on dilutions. Similarly for equivalent conductance, this is also, you see, kappa upon n. So this n is same, we already discussed, that is equal to k upon b. So we already discussed these things in the previous class. So here also that volume dominates upon kappa, so lambda equivalent also increases on dilutions. Okay. So overall summary if we write, then on dilution conductance increases, molar conductance increases, and specific conductance decreases. So these two value will increases and this will decreases. Okay. Why decreases we have discussed, why this increases we have discussed. So let's move to another topic, that is strong electrolytes and weak electrolytes, or that we will discuss in next class. So today after this, thank you.